Hello and welcome! In this video, we will provide an overview of logistic regression as well as a basic implementation in Tensorflow. Logistic regression is an important tool for machine learning and a great stepping stone for learning about more advanced models and algorithms. You might be familiar with linear regression, which is a useful tool for estimating continuous values like housing prices, for example. But if we need to perform classification and determine which class a data point is likely to belong to, then we need to use a different type of model. This is where logistic regression comes in. Logistic regression provides a formula that predicts the likelihood that a given input belongs to a certain class. The model makes these predictions by analyzing the data's features, which are a set of independent variables that describe the data. Intuitively, logistic regression takes in a series of inputs and passes them through a set of three functions. First, the inputs are multiplied by a set of values known as the weights. The weight values represent the relative amount of emphasis to put on each feature of the input. The model improves its classification ability by gradually updating these weights throughout the training process. The weight multiplied value is then fed into another function, which adds on an additional value called a bias. A bias is an important value that increases the flexibility of our model beyond what a set of weights could do alone. And like the weights, the bias is also updated throughout the training process. Our last step is to feed the resulting sum into something called a sigmoid function. The sigmoid function will map the sum onto a curve that represents the probability of the input belonging to a certain class. After loading your dataset, it's easy to create this three-function model with Tensorflow. We first need to implement the weight multiplication, which we'll do by using the mat_mul function. Mat_mul simply stands for matrix multiplication, and this function receives our input and the weights as parameters. We then take the result of the matrix multiplication step and use the add function to add on the bias. And finally, we pass the sum through the nn.sigmoid function. At this point, you should understand the purpose of logistic regression and how to implement a three-function model in Tensorflow. Thank you for watching this video.